Rhombus, circumscribed, angles, this thing. It's geometry. With me, Miss Cohen.
Hello. This is our last lesson in our first unit. It's lesson 3.1 and 3.2 out of the textbook that we never use. And the title today is Series of Transformations. I'm on page 27. I don't know where you are. So go ahead and fill out your table of contents. Pause this if you need to. And then turn to your next new page. And the good news today is that our notes consist of just one example, and that is it. The bad news is that you have quite a bit just to copy down. So right now, what I would like for you to do is pause the video, get all of this down. Please use a straight edge and be really precise with your figure, because otherwise this won't work for you. So ready, pause. And we're back. So this is a lot of stuff. This is called a series of transformations because what we're doing is we're taking an original figure. In this case, we have a triangle, a right triangle, ABC, and we're doing 3 transformations to it. And I can see there are 3 because there are 3 arrows, and each arrow represents a transformation. So first we'll be applying this rule, and then we'll have 3 new points. And then from our 3 new points, we're going to apply this rule. And so every rule is applied to the new figure that you got in the preceding rule. And so what I always do when I first look at something like this, just to make it a little less overwhelming, is I try to think about what each transformation is going to do. So this first one, if I'm subtracting 1 from x and subtracting 1 from y, when we add and subtract to our variables, that's a translation. And so here, I want you to think about, are we moving, well, I should say this, how far up, down, left, or right are we moving? So I want you to just think about that for a minute. And hopefully you figured out that here we're moving left 1, and then here we will be moving down 1. So our first transformation is going to be easy. It's just a translation. I wrote 2. That should be a 1. It's just a translation, and we don't really need to use coordinate notation to do that, but I'm going to because I'll need it for my next transformation. And my next transformation is non-rigid. And I know that because I'm multiplying one of my variables by something, and that's going to stretch it. We haven't done that a lot, but what this is going to do is stretch my figure in a left-right way, because this is my left-right variable x. So this is going to be a horizontal stretch. So it should get 3 times as wide, but the height shouldn't change because y is unchanged here. And then my last transformation, this is just a rule that I happen to know and you may not yet, but this is going to be a 180-degree rotation. Sometimes instead of giving you these rules, it'll actually say, first, translate your figure 1 to the left and 1 down. Next, do a horizontal stretch of 3, and then do a 180-degree rotation. And if it did that, you would have to pull these rules and write them down. But in this example, they were given to us. So we're going to start, forgive my zooming, we're going to start by applying coordinate notation to our first rule. And before we do that, we really need to make sure we have written down our points. So point A is 2, 2. Point B is 2, 5. Point C is 3, 2. And then every time we transform a point, it becomes A prime, right? So we'll say A prime, and then we'll have B prime, and we'll have C prime, and we'll have 3 new points. So this is our pre-image, and this will be our image. And I could do this really easily just by taking each point and sliding it left 1 and down 1 and getting a new point, but I need the coordinates anyway, so I'm going to go ahead and do x minus 1 and y minus 1. So I'll take this and subtract 1, and then I'll take my y and subtract 1, and that gives me my new point. Take a minute on your own and go ahead and do B prime and C prime. When you're done, just check up here to make sure yours match mine, and then go ahead and graph that figure. It's important, I'm just going to talk while I work here. It's important to graph them as you go, otherwise it starts to get really confusing, like which triangle is which. So graph them as you go, and most importantly, label your points. If you have colored pencils or something like that, this is where those will come in really handy. So there we go. And just like we thought, it's a translation, one to the left and one down. Okay, our next transformation is this horizontal stretch. And then one thing that's new is now we're applying a transformation to A prime. And so we're actually going to call this A double prime, and it's an A with two little prime marks next to it. And then we'll have B double prime, and we'll have C double prime. And that will show us that this is our second transformation because it has two little primes. And so this says take X, multiply it by 3, leave Y unchanged. So remember, I'm not going back to my original figure. I'm using the one that came right before. I'm going to take X and multiply it by 3. 1 times 3 is 3. Y remains unchanged. Again, I'm going to take X, multiply it by 3. 1 times 3 is 3. Y remains unchanged. Go ahead and do C double prime. And hopefully you got 6, 1. Graph it. And again, the colored pens and pencils come in handy, but it's also really useful to label your points because now I can really see this is my pre-image, no prime marks. This is my first transformation because they have 1 prime mark, and this is my second transformation because it has 2. And we're almost done. Our last transformation is this 180-degree rotation. So you hopefully guessed if we have A prime, A double prime, this will be A triple prime. Starts to get really crowded because we are doing our third transformation. And remember, we're applying it just to the one that came before. So this says do the opposite of X, do the opposite of Y. No funny business of flipping them or anything like that, like swapping them. We're just taking what's positive and making it negative, taking what's negative and making it positive. So 3 and 1 will become -3 and -1. And I'd like you to go ahead and finish with B triple prime and C triple prime. Check up here to make sure you did it right, and if you did, go ahead and graph it. And there's our last triangle. It's so pretty. So what's cool is that you can actually see the transformations that we discussed, right? First we took our triangle and we translated it. That was a rigid transformation. Then we stretched it to be 3 times wider, and you can see that my green triangle is 3 times wider than the red triangle. It looks like there's a translation, but there wasn't a translation there. It's just that everything sort of exploded from the origin, got 3 times as far away from the origin. And then we took that triangle and we rotated it 180 degrees, and it became our last blue triangle. So that is how to do a series of transformations. The most important thing that I can tell you is that it is really necessary almost in every case to do this process because otherwise it's really difficult to keep track of all of this. The only exception is if you're doing translations and reflections over the axes, because for those you can really do them just by looking, but for the rest of them you do need that coordinate notation. So we're done with notes. I would like you to write a summary and I'll kind of help you get started. When you write your summary, I just want to make sure that you understood the lesson. So the question was, how do you apply a series of transformations to a figure? And so I would start by saying, turn the question around to apply a series of transformations to a figure. And then explain in your own words how to do it.